Okay, class, I've had an email question about number 59 and number 97 and number 37 on the review. So I'm just going to run through these real quick for you. We're asked to graph y equals 4 sine of 2x plus 4 minus 2. So because I realize that I'm going to have a sine function with a downward shift with this -2, I'm actually going to focus all of my attention first on graphing this, and then I'll just move it down too. So to graph that, first thing I do is I take the argument of the trig function, which is this. I set that equal to 0. I set that equal to 2 pi. Moving through and solving, I should get x is -2, and then x is pi minus 2. Just be careful here. All I did is from this step, I divided each term in the numerator by 2. So that gave me 2 pi divided by 2 is pi, and -4 divided by 2 gave me -2. So now what I do is I plot those 2 points on a line here, and then I look and I try and find this point that's right in the middle. And what I'm really doing is I'm trying to find, there's going to be a total of 5 points here. I need to find the one that's halfway, and then the one that's halfway between, sorry, I should say the one that's halfway between those two, which is this one, and then the one halfway between these two, and then the one halfway between those two. So I'm trying to find all those. So to figure out the halfway point right here, what I do is I take the two endpoints, I add them, which is here, I divide by 2. So if I do that, I get this, and that's going to be this middle point. Let me get all that out of here. Okay. Then what I do is I look at this point here and this point here. I add them, so that's this point and this point, and then I divide by 2. And be careful here when you add the top two here together, you have to get a common denominator. So I multiplied this one, it was over 1. I multiplied by 2 and 2 here, which is why I get a -4 there. And then I add the numerator over here, which gives me this. And then remember, now I have a common denominator of 2. So putting the top together, I get this. And then when I come through and take this fraction, I divide by 2. It has the effect of doubling this denominator, which is why I get a 4 there. So I hope that all makes sense. Get that out of here. Okay, so this point is going to go here. And now what I'd like to do is I'd like to find the point between here and here. So I take those 2 points, I add them together. Again, I need a common denominator, so I need to take this over 1. I multiply the top and bottom here by 2. The 2 distributes, which is why I get this. And then I add it to the other numerator, which was that one. I divide the whole thing by 2. That's my common denominator here. And then the whole thing is divided by 2 because I'm taking the average. And then if you put those together, you should get that. And that's this point right here. All right. Again, let me get all that out of here. Okay. So we would have had these 5 points, and now what I need to do is determine how this graph behaves. So I know it's a sine function, so anytime I have a sine function, I have my 5 points. I know that the endpoints and the middle point will be 0, and that's because it's a sine function. Had it been a cosine function, then the only thing I know is that my cosine function is 0 here and here. So in the sine, I have to figure out if it goes like that or if it goes like that. On the cosine, I have to figure out if it goes like this or if it goes like this. So for sine, all I'm really going to need to do, since I know that these points are 0 here, here, and here, is I'm going to pick a test point, which I'm going to plug this pi minus 8 over 4. I'm going to plug it into the original function and see what comes out. So here's me plugging it in for x, and then I'm distributing through. Actually, what I do is I reduce that by 2 there, like that. And then I get the pi minus 8 on top over 2. And then I split this into two fractions. I do pi over 2, which is here, and then I do negative 8 over 2, which is negative 4. Then these 4 and negative 4 cancel, so I'm just left with the sign pi over 2. 4 is 4. Sine of pi over 2 is 1. 4 times 1 is 4. So I know at this point at pi minus 8 over 4, I know I need to go up 4 units and put a dot, and that's where that dot right there comes from. And then once I know that, then I know over here on this other one that I must go down 4 units. So you get that 1 point gave me the full behavior of this sine curve. And now at this point I kind of draw a dotted line that shows my graph here. I've got this dotted line. And then what I do is I bring in the shift. I move every point down 2. So this point used to be at 0 on the y. So I bring it down y 2 units to negative 2. This one used to be at 4. I bring it down 2 units. So now it's over here at y equals 2. This one used to be at 0. I bring it down 2. So now the y coordinate here is negative 2. I bring this one, which used to be at negative 4, down to negative 6. This one at 0, I bring it down 2 to here. And then I draw my sine curve through there. It's in red. So that's pretty much what I'm looking for. All right, the next problem. Now this problem is somewhat involved, and I would consider this more of like a bonus problem because we have not, a bonus problem on the test, because we haven't really covered it, but I wanted to put it on the review to see how many people would actually go and try and attack this and see what happened when they ran into trouble. So we had like a building, and then we had like land, and then we had over here was water, and then we had like a ship or something. They gave you that this was 5 degrees, the angle of elevation up to the top of this building. They told you that this distance from here to the shoreline was 1 mile. Now since the height of the building was given in feet and the distance here was given in miles, we need to convert the mile over to feet. So 1 mile is 5,280 feet. So what I also want you to notice is we're trying to find the distance from the shoreline to the boat. I'm calling that x. And notice we can create 2 right triangles here. We have a big right triangle, which is created by the building and the boat, and we have a smaller triangle, which is created from the shoreline to the boat. And I want to look at those 2 triangles separately. So the big one here has a side. This side over here is 1454. The angle is still 5 degrees, and then notice that this side here is this distance, 5280, plus the x here. So that's what I put here, x plus 5280. Then the smaller triangle has an angle of 5 still. This side is x. This side, I don't know how high that is, so I'm going to call it h. Now, there's a property of similar triangles that says that if you have similar triangles, meaning that you have all the angles match up. So I have a 5-degree angle here, 5-degree angle here. I have a 90-degree angle here, 90-degree angle here, which means that these 2 angles have to be the same. If you have triangles where all the angles are the same, they're called similar triangles. And that means that the ratio of the sides are equal. So that means that I can take this side of this triangle and divide it by this side. That's a ratio, which I've done here. And that must be equal to the same corresponding side, which was that adjacent side divided by that opposite side of the other triangle, which is here and here. That ratio must be the same. So now what I'm going to do is I'm going to try and figure out what h is. So I multiply both sides by h here. When I do that, this h will have to distribute through. But let's not do that. Let's just realize that that h is on the top here. And then I would like to get the h by itself, so I'm going to get this 1454 off this side by multiplying 1454 on this side and 1454 on this side. So what winds up happening is my h is canceled on the right, my 1454 is canceled on the left, and I'm left with this h times this, which is here. I'm left with the x times the 1454, which is here. Now remember, I'm trying to solve for h, and you'll see why here in a second. I'm trying to solve for h, so all I'm going to do is divide both sides by this entire thing, and h will be there by itself. So I take the 1454x, I divide it by everything in the parentheses there, here, and now I have an equation for x. Now, come back to this triangle right here and replace h with what we just found, which is right here. And now notice we have a triangle. We have an adjacent side, we have an opposite side, and we know the angle of this triangle, and we're trying to figure out what x is. So if I just set up this trig function, we know that tangent is opposite over adjacent. So tangent of 5 degrees should be the opposite side, which is this one, divided by the adjacent side, which is x. So what happens here is on my calculator, I can do tangent of 5 degrees and get this. Make sure that you're in degree mode. And then when you divide this bottom x is really x over 1, so it flips up here, becomes 1 over x. It's gone down here. The x's cancel, and all you're left with is this. And then on the left side, of course, we said we had a number. And check this out. This is an equation that only has x in it now. So I'm going to be able to figure out what x is. So I multiply both sides of this equation by this denominator. So I multiply that here, and I multiply it here. I know that on the right side, they will cancel. On the left side, it'll be that thing, which is this now, times this number, which I just put out in front. On the right side, the only thing left is the 1454. Then I distribute this decimal through. So I multiply this times x, I get this. I multiply the 0.08749 times 5280. I get approximately 461.9472. And now I'm almost there. I can just move this to the other side by subtracting it, which gives me this on the right side. And then I still have the left side as 0.08749. I will divide through by 0.08749. So I divide this by that, and you get 11,339.0422. That's how many feet x is. But we're going to answer it in miles, so we divide that answer. We divide that by 5280. When we do that, we get approximately 2.1 miles. That's a pretty interesting problem. I would probably not expect you to be able to do that necessarily right off the top, but like I said, as a bonus problem, this might be something a student would be able to handle, especially if you took the time to ask me for help, which someone did. So, all right. Now, number 37, I actually told you not to do this because we hadn't covered it, but I'm here, I'm doing a video, I may as well just show you how to do this. That's what I'll show you in class next time after our test. I'm trying to rewrite this, and I'm trying to rewrite it where you don't have any trig functions involved anymore. So I'm going to do some weird stuff here. I'm trying to find what cosine of sine inverse of u is. So where I have this sine inverse of u, I'm going to make a substitution. I'm going to call that whole thing w. So I'm letting w equal that arc sine of u. Then the next step, I'm going to take the sine on both sides of this equation. So I'm coming here, I'm going sine of w, on this side sine of arc sine of u. We know on the right side that's putting sine and arc sine together, they wipe out, you should just get the u. And then on the left side, you still have sine of w. Now, if I look at this and take this statement, sine of w equals u, I can rewrite this, or I can draw what we call the reference triangle. Reference triangle. The reference triangle says my angle should be w, so I call that w. Sine is u, which means that sine was opposite over the hypotenuse. That should be equal to u, but u is the same as u over 1. That means my opposite side would be u, and then my hypotenuse would be 1. So I labeled my triangle that way. So this triangle represents, I don't like that. This triangle here, right here, is a geometric or visual representation of this equation. And what's really interesting about this is that if we go back and look at what we were trying to figure out, right? We wanted to know what cosine of sine inverse of u was. But sine inverse of u is w. So we really wanted to know what cosine of w is. Well, go to our triangle, right? The angle here is w. Cosine is the adjacent side divided by the hypotenuse. Well, I know what the hypotenuse is. It's 1. I just need to figure out what the adjacent side is. So I just use a Pythagorean identity that says that a squared plus b squared equals c squared. So in this case, my adjacent side squared plus u, that's my other leg of the triangle, squared must be equal to the hypotenuse, which is 1 squared. I square one, I get 1. I bring the u squared to the other side, and then I just need to know what adjacent, take out the squared on the adjacent, so I take the square root of both sides. So I know that the adjacent side of that triangle is the square root of 1 minus u squared. So now looking at this new reference triangle, which is this same reference triangle with the added detail of this leg of the triangle also, I can now talk about what this is. Cosine of sine inverse of u, we said, was cosine of w, but cosine of w was this adjacent over 1. So square root of 1 minus u squared over 1 is this. So this expression is equivalent to this expression, and that's what we're looking for. Now there are some restrictions that we have on u because the way we defined the arc sine, we know that u had to be between, negative pi over 2 and pi over 2. But as long as our u is in there, then plugging u into this would be the same as plugging u into this. So it's pretty cool that we can take some composition of a trig function and an inverse trig function and somehow come up with just a purely algebraic expression that's equivalent to that one. So we'll spend more time on that. I won't ask you that on the test. Probably won't offer it as a bonus either. I don't know. I have to make the test first. But someone asked, so I thought I would show you. All right, that's it.